Hi all, thank you very much for the opportunity to speak with you guys here today. This is a project to which I'm very personally excited about and I'm very happy to share with you. Now, one thing that's going to be a little different about this presentation is we're all here at a technology platform conference and we're going to talk about a lot about technology and the underlying data of how to do the work that we do better, quicker, and more efficiently. That's actually the one thing I'm not going to talk about here today. Like, we actually have a second talk from TD Bank about our technology migration platform to Azure. And that's going to be at 3:30 with my colleagues Paul Wellman and Upal Hussain. So if you're interested in the technology side, I encourage you to come back and see that talk. And before I begin with my talk, I just want to do a quick shout out to all of our virtual viewers. Thank you very much for attending this presentation. Unfortunately, there's no means for you to directly ask questions during the presentation, but I encourage you and actually everyone here in the audience right now to reach out, connect with me on LinkedIn, and I will be delighted to answer any questions I have. So with that, I will begin. I work for TD Bank. We are a brick and mortar institution, a very traditional corporation, and I'd like to get some of the stereotypes out of the way. There is a reputation that traditional corporations, particularly in this space, are very glacial and they are very hard to move. And so this kind of complex, cutting-edge project just isn't possible to be done. And I would like to be here to dispel that myth. I'm not going to say that it's easy. I'm not going to say that we figured it all out and that it's going to be magically and that tomorrow we're going to be working in the cloud and everything's going to be great. But I want to say that it can be done, and I think it's really important that it is done. And in order for us to do this kind of work, the work that really has meaning and value to our customers, we have to really be cognizant of three very separate domains. The first is obviously technology, which is why we're here. And the second is the modeling and the programming and the development of the data science, which we're all very comfortable with. That's the part that really interests us. It's certainly the part that interests me. But I want to talk about the business side. And so this talk is going to be presented as a business use case. I'm going to tell you a story about how we did a project. And along the way, I want to try to highlight the business issues and the business barriers that were necessary to be overcome for something like this to be a success. Because it really is only when you have all three parts coming together that you can achieve this kind of cutting-edge work. So what is this work? What is FutureMetrics? FutureMetrics is a way of forecasting the future. It's a way of taking economic data and trying to project in the future so we can make business strategy decisions. And if you were in the keynote this morning, you saw that great chart where he showed the upward curve, and he said over here is business analytics, and over here is AI-driven business strategy. This is the barrier we're trying to leap across. We're trying to get from the point of not just simply producing numbers, but producing models that drive strategy. And so that's the goal here. So how do we create cutting-edge data science at a traditional corporation? Well, it takes three things. And some parts of this presentation are going to be a little counterintuitive. But number one, you have to have alignment. You have to basically understand your business. Who is your line of business? Who is your client? Take your time, get to know them. The second one is accelerating mistakes. Now, this is probably the most counterintuitive. I'm not telling you not to make mistakes. I'm telling you to make more of them. And I'll get back to that in a little bit later, but that's really critical. Then finally, we have to look at how we build capability. We have to look at how we use our most valuable resource in the organization, our employees. So I'm going to take a little bit of a step back here, give you guys a little background. I work for TD Bank. It stands for Toronto Dominion. We're about 170 years old, I believe. We started actually, it was Toronto Bank in the middle of the 19th century. We are the largest of the big five banks in Canada. Not 1855, 1955, excuse me. We have over 1.8 trillion in assets. And one of the key things that I really like working about TD Bank is this last one, that we have this philosophy of trust. We are known, particularly among banks, which is a fairly, well, somewhat, it was calculated risk-taking history as being very, very low risk. We hold it sacred that this is your money, you trust it with us, it is in our care. That way, not taking risk, we're really quite risk-averse as a result. But that's okay because that's how much we value your money and we want you to feel secure in your relationship with us. Now, that can be a little frustrating sometimes as a data scientist. I'm a change maker. I want to make changes. Sometimes I go to them with a really well thought out, well developed proposition, and I sometimes get, well, I don't know. And that happens. That happens a lot in a corporation. And overcoming that is one of the key priorities of my job. So there's sometimes I'm really excited to be a data scientist. There's sometimes we get to do some really cool stuff, and our job mimics the world of science fiction. So Isaac Asimov was writing back in the 1950s and thereabouts, and he postulated something called psychohistory, which is really the forerunner of today's data science. And the purpose of the psychohistory was to predict the future, but not just any future, the future after the collapse of an empire hundreds of years into the future. And then, from there, to build on the strategy and modeling tools in order to restore a new government and a new stability after time interregnum. And the challenge here was he wasn't going to stop the fall. The fall was going to happen. He couldn't stop that. But he could predict how to rebuild. And that is really exciting to us as a possibility for really any organization and any institution. We live in a time of uncertainty and change. There are talks of economic collapse and other problems coming forth in the middle of the 20th century. Global warming is a real crisis. It would be great if we could have tools that could bridge that divide, that could cross over events that fundamentally change the way our economies work, our societies work, and then produce a tool that can produce useful information after that change, even if we have no data in that future period. And so that was the challenge that we set for ourselves in this project and the thing that we were ultimately hoping to build. So I'm going to, as I said, this was a use case, so I want to take you through the entire story. First off, I'm going to tell you about who we are as a team. I work for Enterprise Analytics, and I'm going to tell you what our job is and everything else. Then I'm going to tell you about back in January of 2021, we were invited in by Liquidity to do a forecasting problem for them. I'll tell you about how we built that model for them, and then ultimately how we decided from that point to move forward into some really cutting edge research. Normally, we do a job, we come, we go, we're done, but in this case, we wanted to go further, and I'm going to tell you about why. So who are we? So I'm, as I said, Enterprise Analytics. We are an in-house consulting squad. So we go around every line of business across the enterprise and we solve business problems. That means we only have about 3 to 6 months to do it. So immediately, within a matter of weeks, we have to understand your business. We have to understand how you do your job. We have to understand how you make your decisions. If you're in mortgages, how do you decide what a mortgage is? What do you consider risky? What do you consider priorities in your mortgage balance portfolio? All of these things are really critical to us producing a successful project. Now, because of that, we have to really walk a mile in your shoes. We have to be very, very, very closely aligned with the way your business works. And because of that, we're successful. The average data science project in a major corporation, the success rate is only about 25%. Our team has over a 75% success rate because we take this time and effort and we work directly with every line of business, meaning that with many members of the line of business as frequently as daily. So we have people we meet with daily, people we meet with weekly, people we meet with monthly. But all of this time is a process for us to learn how they do their job and to make sure we're building the right tool for them. Our priorities are in many ways more straightforward. We want to drive value. We want to promote the adoption of enterprise-level adoptions and processes. We want to simplify and optimize how we do business. Now, this actually turns out, while it sounds simple, it's actually a much more challenging prospect. Finally, we want to grow our talent, and that's not just in our team, but across the enterprise. We are a flagship team, a center of excellence, so we have responsibilities across the board. Now, on this side, I'm going to, unfortunately, convince you that some of the stereotypes of working for a large corporation are true. There are many technology companies which can put out a model into production in a matter of days. That is not TD Bank. We are working at about 18 to 20 months. And that is a large part of the very significant regulatory burdens, but also the nature of corporate cultural policies and practices. A corporation is like a machine. It's very hard to change the wheels and rebuild the machine. So you have to work within the frameworks that we have. So like any problem in the model lifecycle, we start with problem ideation. The business line comes to us and asks us to help them solve a problem. Our team does the 2 sections in blue. We work on data access and procurement. and we work on feature engineering and model development. While we are moving to the cloud, specifically Azure and Databricks, right now we have a slew of legacy systems. Every line of business has their own system. It's a big SQL jungle out there. There's also lots of SaaS still lying around. We have a Hadoop data lake. And so there are lots of challenges that come in this phase of the operation, and that's why it can often take 2 to 3 months just simply to get access to all the data that we need to do the process. We will then build a model, and then we'll send it over to model validation. Depending on how long it takes you to write your model document report and everything else, that can be anywhere from 3 to 6 months. And that's where we go through the first round of regulatory review to make sure the model is sound and your money is safe. Finally, we turn it over to the line of business who do their own production and deployment. And then there's ultimately an extensive period of model monitoring and feedback to ensure that the model is working as expected. So liquidity. This is what we are asked to do. Liquidity is basically the ability of the bank to have enough money to loan money. Bank's job, a bank's business, is not to hold your cash. It's not about savings accounts. It's not about checking accounts. A bank's business is fundamentally about loans. In order to make loans, we have to have cash. We have some of that as your checking and savings account. So we want those, and we want those to work well. But our goal is to make mortgages, credit cards, car loans, all of these things. This is a bank's true purpose. Now, in order to make loans, we are required to have enough cash to have on hand if those loans should go on a run. So if something in the economy should collapse, we have to make sure that those loans are backed. This is a regulatory requirement from the federal government, whether you're in Canada or the US. We have to have enough money to back those loans. That is what liquidity is. So you can think of liquidity as the bank within the bank. This is the ability of the bank to do everything that we want to doing. So, but it's not just enough to have enough money today to satisfy all our loans. We have to have money into the future, specifically 90 days into the future. So we have to make sure that in 90 days' time, we have enough money to supply all the funding needs of the bank. Now, we don't like to do this because it's expensive. Every extra amount of cash we hand is money that we're not actually earning money on. So we don't want to overestimate this number. We want to get this number very close. And that makes it actually a very challenging problem. Oops, there we are. So we have $500 billion in assets. We have to hit that target with only a $5 billion buffer, and we have to do so on a 90-day time horizon. This is not a small challenge. Further, sorry for the graphic, but the information is here. Not sure why that's displaying incorrectly. So the first stage, there's actually it's actually many-stage process. So the first thing we have to do is we have to forecast product growth. So we have to know how many mortgages we're gonna have in 90 days, how many savings accounts, how many checking accounts, everything else. That's actually the part of the problem that our team was asked to come in and solve. But that's not the whole story. That's only one piece of what's gonna happen to all these different types of accounts if there's a run. Which sort of deposits can we rely on more or less than everything else? We have to calculate stickiness factors. Different economic scenarios, different degrees of runs. And then ultimately, the question that the bank needs to answer, not my question, but the question the bank needs to answer is, do we have enough bonds to cover the remaining assets that we need to cover? So we sell bonds to raise cash in order to cover our loans. And that's the challenge. So we have to know exactly how many bonds we're going to need in 90 days. That's why I didn't, sorry. There we go. So what this comes out of. So this was the main project that we were hired to do, and this is the project that our team did. We needed to calculate liquidity. We need to get it 90 days and a half based on the product growth forecast. So we created a data pipeline and a model forecast of 70% of the deposit and loan products using state-of-the-art models, as it happens, Facebook Profit, and came up with an answer that was at least 10% over the existing forecast. The existing forecast wasn't very good for a couple reasons. First off, they were marketing forecasts, which meant they were inherently optimistic, and were therefore subject to large bias. I see somebody chuckling there. She knows what I'm talking about. This was not a great system overall, and we were able to provide them a much more reliable system. Now, normally we'd say, hey, $12 million, that's awesome, that's great, let's move on to the next area of the bank, let's go see what we can save there. But we weren't really satisfied. And part of this had to do with COVID. Like, COVID really dramatically changed the economy, and we weren't particularly satisfied with the quality of the model, like, after COVID and everything else. It just, nothing was working in this early time period. And part of it, too, had to do with our own practices. We are a very agile-based shop. We review after every project our policies, our practices. Everyone in the team speaks up and says, I think this works, I think this didn't. And when I say everyone, I mean absolutely everyone, from those junior intern all the way up to the managers. Everybody's in that room going, how did we do? And when we came to the end of this project, we were like, I don't know what to do anymore. Like, we were kind of stuck. And we were stuck for a number of reasons. Like, we have this huge technology stack with 20 different technologies and everything else. But even more than that, we were like, what's our practices? How are we working? Are we working the best that we can work? And so what we said was, we don't know how to go to the next step. We don't know how to bridge that gap between what is just essentially analytics or some informational delivery to the line of business for various reasons, and then coming up with tools that really drive strategy or even maybe make strategy decisions for themselves. And so what we decided to do was, and I thought this was really exciting and I was really proud to be the leadership of this team, was we said, okay, let's, for the first time, we're not going to worry about whether this is going to ever be implemented. We're not going to worry about all the technological challenges. We're not going to worry about the regulatory hurdles. We're not going to worry about any of that. We're going to build the best model we can. And then we're going to back out from that best case model all the reasons why we can't implement it. And I know that sounds a little crazy, but it was incredibly helpful. Like, it taught us all the things we didn't realize and introduced us to all kinds of different barriers to the issues and things. So this is actually the results of the original model. And you can see on the chart of the left, we did really well, loan volumes where predictions are really good and they're much better than the line of business. But you can see on the right, we have this huge lag in Facebook profit. And the reason why we have a lag is because it's a univariate model. It can only respond to the information that it's given. So it's never going to catch up to the actual data that we're interested in understanding and focusing in on. And truly, I think Facebook profit is about as good as any univariate model can be. There's lots of them out there. They're all pretty similar. Most of them are pretty fiddly. Facebook profit's a little similar than most. It does have its issues. But ultimately, at the end of the day, it probably achieves about as good a performance with a univariate model as you can get. So the only way we can go is we have to go further up the ladder, and we have to look at different kinds of models, and we have to get all the way from these. Basically, you can just think about this as a nice ladder of this is the way our team works. We start simple and we work our way up. And in the first case, we worked ourselves up to B, and then we decided we didn't need to C. But we realized, looking back on this ladder, that we needed to go all the way to multivariate. We needed to go to deep learning. And we thought that this would be a very straightforward application of deep learning. We have lots of experience with deep learning on our team. This should be easy. Well, not so much. We immediately hit problems from day one. Just everything turned out, nothing turned out to be easy. Everything turned out to be challenging. We didn't know half of what we needed to know. We didn't even know a quarter of what we needed to know. But what we realized was, okay, good, we made a mistake, fine. Let's embrace that mistake and let's move on to the next mistake. And the first one, our mistake was not having class structure pipelines. As a lot of teams do, we like to work in Jupyter Notebooks. It's easy for analytics. Great. But that doesn't allow 5 or 6 people to work on the same code in the same project at the same time. So if we go to class-structured programming techniques, now 5 or 6 people can work on the same model simultaneously, everyone working on a different piece. The only thing the different people have to know is what each class is outputting from one stage to the next. If they know that, then they can build their part of the program. Building a pipeline took 3 weeks rather than 3 months. From there, we were now able to open up all the other mistakes that we didn't know how to solve then. And that opened the door to thinking about, we had to really deep dive. Basically, time series analysis only comes down to 3 components. It's not predicting the actual values, it's predicting the trend, the seasonality, and in the case of multivariate, the correlation. If you predict those 3, That's enough. You don't have to predict the exact value. It's a little different in thinking. The big one came next, shallow data. For the kinds of systems we're looking at, in most real-world systems, your data is going to be shallow. You're going to have many, many, many more fields than you are going to have X values for those fields. That's not avoidable. Like, I know this is like breaking a cardinal rule of deep learning, but you just got to accept it and move on, because that's the challenge of the problem. Because every economic regime is different. Every time we have a recession, every time we have an economic change, the fundamentals of the economy change. So that means there's only a very limited window of time to which you can sample data, but then you still have to have a model that works that's going to predict the transition that moves after it. So you have to embrace the fact that you're going to be struggling with shallow data, and there's nothing you can do about it. Granger causation is one of the great techniques for lagged and leading correlation, so it was a very useful thing. We had to learn that on the fly. We had to learn that sliding windows were essential. Unlike other models like Facebook Profit, which don't require them, that was essential. Now, you'll see that I have train test buffer split rather than buffer. Data leakage is a huge issue, and especially in time series analysis, it's going to bite you in the butt every single time and multiple times in the same project. Stationarization, this was one of the most challenging, complex projects. I'm not going to really go into in detail, but if you are fundamentally interested in time series problems, come find me afterwards. It's really worth a good discussion. And the mistakes kept coming. We discovered we needed autoencoders. We discovered we needed autoregressors. We had to really think about our architecture for regularization. Dilated combinates proved to be significantly important. Rolling solutions needed to be important. We had to iterate architectures and validate and monitor. Now, all of this sounds like a big mess, but let me point out one thing that's really critical to understand in this process. In 6 months and working on the solution we delivered to Treasury, we tested 1 model. In the 2 months we worked on this POC, we tested 30 models. Thank you. That's the difference that embracing mistakes brings to the table. Everyone feels safe. Everyone feels like they can speak up. Everyone is able to participate at 100% of their ability, not tripping over each other. That's huge. People don't need to be motivated. People need to have the barriers removed from their work, and then they will do better work. So I just want to show you a couple of slides that really just show you how much better this multivariate model did. It's still just a proven concept, and it's not been implemented. But you can see here that this big spike is a dramatic infusion of cash that the Canadian government gave to all of its citizens. And then there was very clearly a new trend in the growth of liquidity. Facebook Profit in blue, or the business profile just didn't do it very good at all. Facebook Profit in blue lagged and then overestimated. It overcompensated. But our model dialed in very quickly to the post-COVID economy. So what's going on? It's responding to the fundamentals and the changes in the economy, and so it's better able to predict that slope. And this plot really just shows you the same thing. But I want to emphasize 2 points. When you're doing future prediction, there are 2 kinds of events. There are predictable events and not predictable events. Don't mix them up. What the Canadian government did in terms of pushing in a surplus of cash, that is not something you're ever going to predict. But the fundamentals of the economy, if you have the right data fields, and that's where it comes into play, those things you can predict and you can incorporate them into your model. Long-term performance, interestingly enough, was actually really good. So this is a 1-year prediction from about, I believe it was April of 2020, so right after the COVID economy changed. And you can see here, for the better part of a year, we're pretty much bang on the money in terms of the growth and changes in liquidity, whereas Facebook Profit continues to overestimate in the same way that it did at a 3-month thing. So it's fundamentally a difference between the univariate covariate models. So the last thing I want to do is talk about how you build capability. We're an agile shop. Now, agile means a lot of things to a lot of different people, and that's okay. The critical thing is that if you want to be good at agile, you got to listen. And at TD Bank, we're very good at doing agile at a pod scale. That is to say, project level, 5 to 6 people. We're really effective, and we can move very quickly, given the speed of the enterprise. However, what we're not very good at is agile at scale. And this is kind of the last remaining challenge that we really have to think about. We have to go to MLOps. And MLOps means that it's not just about a data science team going off and doing a project and building a model on their own. We have to bring in the data engineers, the IT folks, the line of business, the product people. We have to bring them all into the same room as we're designing a solution, because it has to go all the way, and software engineers too, of course, sorry for getting you guys, but like all of these have to be in the room from the beginning. And when you don't have those people in the room, and all you have are the executives in the room, miscommunications occur and things in projects have to be restarted. But one of the great challenges, and the thing that I encourage everybody who works for a traditional brick and mortar corporation, is really speak up for Agile at scale. Because more and more, we're going to have to understand how to do 5 or 10 other jobs that isn't our day job. I'm a data scientist, but I have to understand how software engineers work. I have to understand how the line of business works. I have to understand how mortgages work. I have to do all of these different things. I can't be a software engineer. I can't do that. I need to be able to talk to them. I need to be able to reach them. Because what's going to happen now is like we're going to be building our models, and we're going to be over in this dev environment. And I don't know if any of you guys know about software development environments or who does here. Some of you do well, but I know this may be review for some of you. But most companies have like a dev, pre-pat environment or some, and then they have the true production environment. These are 3 different worlds that are entirely separate with hopefully similar computer architectures, hopefully similar data streams. But the reality is that we end up doing a lot of different work in the software development world, just bringing a piece of software code from dev to pat to prod. And I think we want to start thinking a little bit more smart about how to integrate all these environments. And one of the things that I think we can do that I think is very exciting because of capabilities of the cloud and Databricks is that we can create a containerized environment. If we put that containerized environment at the beginning of the work stream, we can build our prototype in the container. We can make sure that container is configured all the way to the production environment with all the requirements that it has and needs and robustness for production, assuming we're talking to the production engineers and learning all the things we need to do from them. But then what we can do is we can just tie that up with a little bow and hand it off to the next group. And that can really cut down the shape of the process rather than trying to build all of our models in Jupyter notebooks and they have to rebuild from scratch and do everything else. These are the kinds of things that I want us to start taking away from here and to start thinking about how we work our lives more simply, more easily, and we make better use of the most important resource that we have, our employees. So with that, I'm just going to summarize that if you want to do really exciting work like this, and it is so much fun and it is so worth it, do it. 3 things you need to keep in mind. Understand alignment. Walk a mile in their shoes. Understand your client, what they need, what they really need. They may not know themselves at the start of the project. They usually don't. That's okay. Figure it out together. Accelerate your mistakes. Don't be scared of them. Embrace them. That's probably the hardest challenge to do. And then ultimately, build capacity, build connectivity in your organization. If you do these 3 things, you're going to be able to radically amplify the quality of the work that you're able to do and the quantity of it as well.
What were some of the important features in your multivariate model?
So the multivariate model, the features really depended on the feature that was being predicted. So for things like mortgages, a lot of it is what you expect, like housing inventory, 10-year T-bill rate or the equivalent in Canada, things like that. So the important features really depended on which product we were predicting. And so that's where Granger causation became a really, really useful technique because Granger causation will give you the leading correlations for every feature. So that's how we determine that.
I was just wondering, did you do any denoising or any like uncertainty quantification or understanding the uncertainty in your predictions? I assume your data maybe is not that noisy, but yeah, just curious about these 2 things. Thank you.
Right, so no, we didn't need to at this stage in the process. We are actually looking to a data augmentation technique which would allow us to include daily data into the process, and that might require it. A lot of the next stages for this project break down into 2 groups, one of which is, the first is introspection and understanding of our model, so really breaking down statistical understanding, so things like line plots, using TensorBoard to really look at the deep learning neural network and how it's behaving. That's one category. The other category is MLOps style implementation. So we didn't get to a lot of the validation stage and those kinds of things at this point, but that is a high priority for the next stage.
How do you bring data scientists into a new way of working with this kind of cross work with MLOps and data engineers. At our company, we find data scientists sometimes don't like integrating with those teams because they have maybe an aversion to working with software. So how did you kind of reconcile those differences?
I haven't yet. We're still very new at this. I'm kind of the first one dipping my toe in the water to a large extent. But I think there's a universal truth that will apply to your case as well. And for me, the number one important thing about being successful and agile is psychological safety. People need to speak up. So the first thing I teach everybody who comes in new on my team, if I'm leading them of a project, is I want them to ask questions. And I will call on them deliberately, ruthlessly sometimes, to get them to voice their opinion. Because some of the quietest people on my team are ultimately the ones who are going to be the most successful. And so everybody needs to feel safe to ask every question, no matter how stupid. That's really critical. And I think if you can do that, then I think that might help. I don't know.
You talked about shallow data, right? So that's exactly what we are facing for our forecasting project as well. And I know deep learning kind of requires decent amount of data for training purposes and stuff like that. So did you do anything in particular, for example, limiting the number of features in the model, or maybe using a simpler architecture of the deep neural network, that sort of thing? Or
the latter is really critical. Learning how to design an architecture to promote regularization is really key. And that's where autoencoder structure comes in. We like to create bottlenecks. So like really force the neural network down to a really tight point, as tight as we possibly can, before we make a prediction. That's part of it. There's a lot of things that are going on to that, and we're still working on the architecture to get there. But no, actually, we don't reduce the number of features. We only had about 80 data points, only about 80 months of data to train the model on, and we had well over 300 features. And as you can see, we outproduced the Facebook profit model by 5%. And that is still short of the performance we expect to get when we really tune the model architecture the way it needs to be done. I just want to say thank you very much for everybody for your time and attention. It's been a great opportunity to speak with you guys here today. Thank you.